I'm Lauren.
And I'm Tom. But first, I'd like to give a shout out to my girl right there, Brittany Kenny. I got Rambir over here. He's right next to Zach. Mackenzie over there, looking good, Mackenzie. I like that.
Today we're going to demonstrate Newton's 3 laws of motion using different sports.
Let's begin.
Newton's first law states an object at rest remains at rest, and an object in motion will remain in motion with constant velocity until an unbalanced force acts upon it.
Right now, the ball is at rest. It is in equilibrium, which means there's no net force acting on the ball. But when I apply a force by kicking it, the ball moves.
Tom set the ball in motion, but when I stopped the ball with my foot, I applied an opposite force, putting the ball back at rest.
Newton's second law states that acceleration is directly proportional to the magnitude of force applied to the object, but inversely proportional to the mass of the object.
In simpler terms, an object with greater mass will need a bigger force to accelerate it, and the object with smaller mass will need a smaller force to accelerate it. This law is represented by the equation F equals ma, or force equals mass times acceleration.
What we're going to do to demonstrate this law is hit a football and a tennis ball with a tennis racket. Keep in mind that the football has greater mass.
The football didn't go as far because it needed a greater force to accelerate it as far as the tennis ball did. Its third law of motion states all forces come in pairs. For every action, there's an equal and opposite reaction.
Technically, this happens simultaneously, but an action force is needed for a reaction force.
When I hit the ball, I get a stinging sensation in my hand, because I'm not only hitting the ball, but the ball's hitting my stick too.
As the ball enters the cage, the ball will apply a force to the backboard, and then the backboard will apply a force back to the ball.
Since the backboard had a greater mass, it pushed the ball back. But if the ball had a greater mass, it would have created a hole in the wood.
If you watch closely enough, you can see as the ball hits the backboard moves, then causing another force back to the ball. Newton's 3 laws of motion.
We hope you enjoyed our demonstration and have a better understanding of Newton's laws. That's Newton's 3 laws of motion. Tom, can you just be? And there's an equal and opposite reaction. Stop! I didn't good! Object remote. Okay. It's upon it.
Right now, this ball is at rest, which means it's in equilibrium.
Stop!
I messed it up.
Newton's third law states for every action.
What is it?
Stop! Okay, restart. Opposite reaction. All forces come in pairs.
Technically, this happens simultaneously, but an action force needs a reaction force.
No, an action force is needed for there to be a reaction force! Newton's third law states all forces are found in pairs. For every action, there is an equal and opposite reaction.
Technically, this happens simultaneously, but the force needs a force. And the force needs a force of unbalanced forces.
Okay, stop.